Alrighty, in this video we are going to be talking about rate in and rate out problems. And essentially with these types of problems, it's basically a game called can you plug this into the calculator and can you interpret what the question is asking? That's all we're doing here. Nothing too hard. So looking at number one, we have a storage tank and it contains 225 gallons of gasoline at time 0. And during 0 to 10, gasoline is being removed from the tank at a rate of L of t is equal to 3 plus 10 cosine of t squared over 40 gallons per hour. In addition, gasoline is being pumped into the tank at a rate of E of t is equal to 10 over 2 plus ln of t plus 4 gallons per hour. A is asking us, is the amount of gasoline in the tank increasing or decreasing at time t is equal to 4 hours? Now, whenever we are talking about increasing or decreasing, we want to look at the derivative. Thinking about L of t and E of t, it's already the derivative because it's talking about rate, gallons per hour, gallons per hour. So for part A, the only thing that I'm doing here is figuring out that if I have E of t, which is gasoline being pumped in, and then we're going to subtract it from L of t, which is going to be gasoline that I am being removed from the tank. At t is equal to 4 hours, I'm going to have E of 4 minus L of 4. Okay, so this is the part where we are going to play the game of put this into the calculator. There is a specific way that I want you guys to put this into the calculator. I want you guys to go to y equals, and then I want you to type this into your y equals. So I'm going to have 3 plus 10 cosine, and then x squared over 40 for y1. And then for y2, I'm going to have 10 over 2 plus ln of x plus 4. In addition to that, I'm going to have y3, and that's going to be my E of t minus L of t. In this case, E of t is going to be my y2. So I'm going to have y2 minus y1. I don't really care about y2, and I don't really care about y1 that much. So on your calculator, remove that, and the only thing I want is basically y2 minus y1. I'm going to go to second graph or second table to figure out what my time is at 4. And you can see that at 4 that I have negative 9.7592. So this is going to be about negative 9.7592. Now, if it says justify your answer, you're gonna say that the amount of gasoline in the tank at time is equal to 4 hours is decreasing at a rate of 9.7592 gallons per hour. And that's part A. Now, of course, you only need 3 decimal places, but more than 3 is good. Just because you don't want to do something stupid and accidentally round off and then get the problem wrong or something. Part B is saying what is the net change in the number of gallons of gasoline in the tank from 4 to 6. So essentially, this is just asking you from 4 to 6, how much is added or how much is subtracted from your original 225. And essentially, your net change is going to be from integral from 4 to 6 of E of t minus L of t. Now the reason why, oh, in DT, the reason why I had you guys do y2 minus y1 for y3 is because whenever we type this in, I type in the integral, I'm going to type in 4 to 6, and then I'm going to type in y3, just so that it's quicker for me instead of typing in the whole equation, because looking at these problems here, we have all the way to g, we're going to have to use these equations a lot. So for this one, the net change is going to be negative 17.856 gallons. Part C says, what is the average number of gallons of gasoline in the tank from 4 to 6? So remember, average value is going to be 1 over 6 minus 4, and then the integral from 4 to 6. And then, of course, we're going to have E of t minus O of t. But in addition to that, because it is asking us about the average number of gallons of gasoline in that tank, we need to include 225 somewhere in my setup, just so that that is included as part of the oil that's in the tank. So instead of E of t minus L of t dt, I'm also going to include 225. So that is your setup there for part C. And what you're going to do is just type in all of that into the calculator. Notice how here my E of t minus L of t is y3. So here you could just say 1/2 the integral. Oh, well, let me just do this. The integral from 464, insert 1/2 or 0.5. And then we are also going to include 225. And then we're going to get about 216.407 gallons. So this basically means that on average, there's going to be about 216.407 gallons of gas from t is equal to 4 hours to t is equal to 6 hours. Okay, part D says how many gallons of gasoline are in the tank at time t is equal to 7. Once again, we need to include 225 in our answer somewhere, somehow. So we're going to have 225 plus the integral from 0 to 7. And then, of course, your E of t minus L of t dt. Okay, so once again, I have 225 plus the integral from 0 to 7, and then y3. So alpha trace y3 dx, and that's going to be about 161. So we have 161.498 gallons of gas at t is equal to 7 hours. E says express the number of gallons g of x of gasoline in the tank at time t is equal to x as a function of x defined by an integral. So we have g of x is equal to 225, because that's my time 0, plus the integral from 0 to x, and then E of t minus L of t. And that's it. F says, at what time t from 0 to 10 is the number of gallons of gasoline an absolute minimum? Well, to find the absolute minimum, we need the derivative, which, guess what? E of t and L of t are derivatives, so that's great. And plus, if you were to take the derivative of g prime of x, that derivative there is just E of x minus L of x, which, guess what? Same thing. So for F, We want to find my critical point, so we want to figure out when E of x is equal to L of x. So in order to do that, that's essentially when y3 is equal to 0. So we are going to graph this from 0 to 10. So I'm going to go to my window, make sure that I change it from 0 to 10, and then I change my y min and y max to be -1 and +1, just so that it doesn't look weird and wonky. Because I only want to figure out what the 0 is, aka your critical value. So I'm going to graph it. It's right there. Do you know what that is? Probably not. So I'm going to go to second calc, find my 0, find my left bound. Okay, there it is. On my right bound, I guess. You can see that my 0 is going to be 8.1200938. So remember that since this is an absolute minimum, I need to include my endpoint. So I have 0, I have 8.12, 938, and then I have 10. Now, remember that we got to plug this into the original function, aka the one that we found in part E here. So this is going to be 225 plus the integral from 0 to 0 of E of t minus L of t b. That should say t right here. And remember, one of the properties says that if you are taking the integral of the same number, so from 0 to 0, this is going to be 0. So of course, it would make sense at time is equal to 0 that we still have 225 gallons of gas. Now, for 8.12 and for 10, I don't want to do the same thing twice when I can do it one time. I'm going to show you that trick. So, on y equals, on y4, I am going to create an integral from 0 to x. And then I'm going to use y3 because that is my difference, aka my E of t minus L of t. Should have said alpha. Oops. Alpha y3 and then dx. Once you do that, I want you to click second graph, okay, second table, and notice how you have your table. Great. Now, you know what 0 is because that's 0, and you know what 10 is because that's going to be negative 58.853. To figure out what 8.12 is, I want you guys to go to table set, so second window. And then on independent, I want you guys to click on ask. Once you do that, I want you guys to go to second table, and notice how you don't see anything. Because what we just did here, whenever we clicked on ask, was essentially saying that it's going to spit out whatever x value that I want. So in this case, I want 0, I want 8.1200938, and I want 10. And just a reminder, I don't want y3 because y3 is my rate of change, E of x minus L of x. Y4, remember, is that total area right here, the integral. So I want to really look at, oops, don't want to graph it. Oh, great. Okay, y4. So you can see here I have 0, negative 65.89, and then negative 58.85. Now, we're kind of not done yet because I forgot to include something. Notice how here we forgot to include my initial value, which was 225. So you want to include 225, and then maybe set that y3 not equal so that you can only see y4. And here you can see that we have 225, then 159.11, and then 166.15. So our answer here, whenever it says the number of gallons gasoline in the tank in absolute minimum, that's going to be at time 8.1200938, and that's going to have 159.11 gallons. So if I were to write this up, whenever it says justify your answer, this just basically means that at time 8.1200938 hours, the number of gallons of gasoline in the tank attains a relative minimum of, and then my minimum of 159, of 159 and my Apple Pencil isn't working. Isn't that great? Okay. Of 159.113 gallons. That's basically it for part F. Part G says, write but do not solve an equation that could be used to determine time t is equal to k from 0 to 10, for which there are 215 gallons of gasoline in the tank. So it just says write the equation. So just set it up. You're not doing anything fancy. You're not doing anything special except setting it up. So we want 215 gallons. Oops. There are initially 225 at time 0, plus the integral from 0 to k, since time t is equal to k. And then we have e of t minus L of t dt. You're not solving it, you're just setting it up and then calling it a day. So that's part G. Okay, on the next video, I am going to talk about number 2, then maybe number 3, and then number 4, depending on how I feel.